We're going to dig into a pretty wild experiment today. What happens when you decide to build something really, really complex, like a game engine, but your lead programmer, well, it isn't a person at all? This project could seriously change how we think about creating stuff. So let's get into how it all went down. So first off, let's just be clear about how massive of a challenge this is. Building a game engine from scratch, that's a monumental task. I mean, think about something like Unreal Engine or Unity. These aren't just little programs. They're gigantic ecosystems that handle everything from graphics and physics to sound and memory. We're talking huge teams of people working for years. So the idea that one person could pull this off, it's already a pretty wild idea. And then you see this quote, and it all clicks. The person behind this project laid it out so simply. They were the director, the one with the vision. And the coder, the one writing all the complex Rust code, that was Google's Gemini Pro. This isn't just about getting a little help from an AI, you know? This is a whole new way of thinking about a creative partnership.
Okay, so how in the world do you actually manage an AI to build something this complicated? I mean, where do you even start? Well, it all boiled down to the process. The secret sauce was a super strict set of rules, almost like a contract, that laid out exactly how they would work together. It's what kept the whole thing from turning into a total mess.
The whole thing worked because the roles were crystal clear. You had the human director, they're the boss, the one with the vision, the one who makes the final call. Then you had the AI Rust coder. Its job was to execute, plain and simple. Now, the AI could suggest ways to do things, but at the end of the day, the director's decision was final. And, this part is huge, the AI was told point blank, you don't argue about the design. So this collaboration ran on a really strict set of rules. And we're not talking about gentle guidelines here. These were the absolute laws of the project, and they were designed to make everything predictable and super efficient.
And that brings us to the most important rule of all. The creator actually calls it the golden rule, and honestly, it's the key to this whole thing. It's deceptively simple. Every single time the AI gave back code, it had to be the entire file, 100%.
That's right, no shortcuts. The AI was explicitly forbidden from sending just a little snippet or partial code or saying, hey, the rest of the code stays the same. Nope, none of that. Every output, every single time, had to be the whole file from top to bottom. And yeah, that might sound kind of inefficient at first, but it was actually the secret to making this whole workflow sing. So you're probably asking, why be so strict about this? Well, it's because it made the human's job, the director's job, dead simple. All they had to do was copy the entire block of code and paste it. That's it. There's no chance of messing up, no putting a snippet in the wrong spot, no weird errors. It just worked. It meant the code was always complete, always readable, and always perfectly formatted. So with these rules in place, what you end up with is this really clean, turn-based process. It's almost like a very structured conversation or a game, where each side knows exactly when it's their turn to act. It's a clear path from just an idea all the way to finished working code. Here's how that loop worked, every single time. Step 1, the director throws out an idea. Hey, let's add a new feature. Step 2, the AI comes back with a proposal, a plan for how to build it. Step 3, and this is the really important one, the director has to approve that plan. Nothing happens without a green light. And only then do you get to step 4. The AI gets to work and delivers the complete code file, sticking to that golden rule. That little approval step was the key to making sure the project never went off the rails.
And here's another brilliant little rule they called the status mandate. Basically, after the AI sent over a file, it wasn't done. It had to give a little report. Okay, I just sent you this file, here's what's left to do, and here's whether the whole task is complete. It's so simple, right? But it meant the director was never in the dark, never wondering what was going on. It kept everything perfectly clear.
All right, the process sounds amazing in theory, doesn't it? But here's the billion-dollar question. Did it actually work? Did all these rules and loops produce a real, functional game engine? Well, let's take a look at the evidence. And the answer is a resounding yes. If you look at the project's file structure, it's not a mess, it's clean. You can see all the key pieces you'd expect. Main.rs for the core engine, assets.rs for all the game data, config.rs for settings. This is the blueprint of a real, honest-to-goodness piece of software. Let's dive a little deeper into one of those, assets.rs. You can think of this file as the data backbone of the whole engine. It defines literally everything the game needs to work with, what a sprite is, how an animation plays, what a sound effect sounds like. And look at the kind of stuff the AI was building in there. We're not talking about simple variables. It was creating genuinely complex data structures for things like physics materials, sprites and animations, sound effects, and get this, even a whole music system with notes, patterns, and entire songs. This is seriously sophisticated work. Okay, so if assets.rs is the backbone, then main.rs is the beating heart of the engine. This is the file that makes everything go. It runs the main game loop, it draws everything on the screen, it listens for your keyboard presses, it ties all the other pieces together. And that one file, it's over 400 lines of dense, complex Rust code that's basically conducting this entire orchestra of systems. And every single line was generated by the AI, following that strict process we talked about. This isn't just a cool idea anymore. This is proof that it works. So, what's the big takeaway from all this? When you see an experiment like this actually succeed, it really makes you think about the future. It hints at a fundamental shift in how we might build things, maybe moving away from being a hands-on coder and more towards being a high-level director. So think about what this means for anyone who builds stuff. Your value might not be in how fast you can type out code anymore. Instead, it shifts to how well you can think at a high level, how you design systems, how clearly you can communicate your vision. The most important skill becomes creating a solid process. And what's really exciting is that this opens the door for a single person to tackle huge projects that used to require a whole team. And really, this one quote says it all. It's an actual instruction given to the AI, and it perfectly captures the philosophy. If you provide a snippet, you break the workflow. It's a powerful reminder that the whole system was built to serve the human, to make their job as easy and foolproof as possible. The tech has to fit the process, not the other way around. So that leaves us with a pretty big question to chew on. As these AI tools get more and more powerful, what does our role become? Are we still going to be the ones in the trenches, building everything line by line? Or is our future going to be about directing these incredibly capable partners to bring our biggest, wildest ideas to life?